Welcome to today's TSP2 Bridge Preservation webinar. My name is Bill Oliva, and I'm the Chief of Structures Development at the Wisconsin Department of Transportation. I also currently serve as the Chair of the Midwest Region Bridge Preservation Partnership. Today's topic in our webinar is related to bridge preservation using deck overlays. First speaker today is going to be Pat Martens, who is the Bridge Engineering Consultant Representative of Bridge Preservation and Inspection Services. Pat will be presenting an overview of high-performance latex modified concrete overlays. Take it away, Pat.
All right, great. Thanks. Thank you, Bill. Appreciate that. While the title of my presentation refers to the overview of high-performance latex modified concrete overlays, much of the information I have here really applies to cementitious concrete overlays in general. There are a variety of dense concrete overlays out there that agencies use, and one of the most common being the latex modified concrete. But microsilica concretes out there, and to a lesser degree, low slump concretes. Many states have even formulated their own proprietary type mixes. Ohio, for example, has what they call an SDC, or a super plasticized dense concrete, that several of their districts like and use. Illinois has recently been working with some mixes that have fly ash or ground granulated blast furnace slag. And there are others out there depending on the state. So first of all, what are the advantages of these cementitious concretes as an overlay? Well, for one, they are rather robust systems. They are structural concrete mixes, especially designed to provide density or permeability resistance to minimize the infiltration of chemicals and moisture into the deck, thereby protecting the reinforcing steel. The service life of these systems will vary with the type of overlay being used, the soundness of the deck it's placed on, and the detail to preparation given. Some of these overlays have been performing for 30 to 40 years in service, so they have the ability to achieve long life in the right circumstances, in addition to shielding and protecting the existing deck. Then you also need to understand all types of overlays are wearing surfaces, and they are sacrificial systems. They're designed to perform for a certain period of time, and then you take them off and replenish them. And that often gets kind of lost in the grand scheme of things with these overlay systems. So what are these mixes and what differentiates them? I'm going to talk mainly about the latex modified concrete, but I'll touch on the others as well. Latex concretes are Portland cement based concrete that includes the addition of styrene butadiene polymers in the form of an emulsion. And these polymers account for about 15% as a percentage of the cement solids. And it's how the solids react and disperse within the mix that creates its ability to waterproof the concrete. During hydration, as the water is used up, the polymers remain and bond to themselves and the various components within the mix, creating a waterproof system within the concrete, and also a tenacious bond with the surface it's placed on. Latex acts similar to a water reducer, and in doing so, the concrete takes on many of the attributes that a water-reducing admixture might typically provide in concrete, most of which help to improve the concrete quality overall. This is probably the most popular of the dense cementitious overlays out there, and the longest lasting. They're used by no fewer than a couple dozen states or so in some capacity, and they've been around for over 50 years, so they've withstood the test of time. Developed by Dow Chemical in the late 1960s, it was specifically designed as a concrete overlay system to protect our bridge decks. There are alternates out there, though, that do compete. The most popular probably being the microsilica concretes, which use waste material from an industrial manufacturing process. The addition of the silica fume creates high compressive and flexural strengths and bond strengths, as well as providing a reduced permeability. It's a ready mix type product, whereas your latex concrete is going to be placed through a volumetric type of mixer. Low slump concretes are another mobile mix type product, and that's kind of just what the name implies there. It combines a mix design with a 1-inch slump and a high cement content to produce a low water cement ratio and a densified concrete. I think Iowa was kind of the developer of this type of mix, and they've used it for a long time, and it's still kind of their standard go-to mix out there. The real key to the performance of these overlays is whichever one you're using, it's going to be in the bond. It's like that with so many of the products we use out there, be it an overlay or a joint system or coating. They all demand a certain level of prep, and a concrete overlay is no different. First of all, the deck must be structurally sound. Your overlay is only as good as what you're putting it down on. That means no delaminations or microfracturing left behind within the deck. And you also want to provide a good surface profile. The more roughened, the better, because it gives so much more surface area for the overlays to bond to. That's why you'll often hear these system installations mentioned in conjunction with a hydroblasted surface in order to gain better profile than what a plain milled surface might give. With hydrodemolition, it's likely you can get upwards of 300 to 400% more bondable surface area for your overlay to grab to. Of course, you also need a clean surface to lay the material on. Dirt and oils left behind create the potential for a bond breaker. And then something else that's critical for a latex modified concrete installation in particular is that you have a very well saturated surface. So that deck needs to be thoroughly watered down to the point of refusal to put it in a good saturated surface dry condition. You just have to watch the balance there so you don't allow ponding, as that can reduce the quality of the concrete at the interface and also create a bond breaker type situation between the overlay and the deck. Now, most people probably think of these cementitious overlays as more for rehabilitation work, and they do tend to get used for this purpose a lot. Really, when we look at how latex modified concrete successfully used, there are 4 different approaches that all work real well. First of all, these systems have been used on brand new bridge decks to make for a good preservation treatment to provide immediate protection of the deck and keep chlorides from intruding. You tend to see this more with agencies trying to protect their investment in big river bridges or larger viaduct type structures. When used in this capacity, latex can easily provide upwards of 30 years and beyond of protection. And then when the overlay is pulled off, you often have little to no chloride entry into the actual deck. A good second option, though, is to provide a more protective restoration before the deck starts to take in too much chlorides and the corrosion process gets going. So if you go in at about a 15 to 20 or maybe even a 25-year mark early on in the life of the bridge and prep and apply a good latex concrete system on a sound surface, it's going to provide a good long-term protection for you. Third option is that more intense rehab that we see most of the time with these systems, where generally you're going in and taking care of a substantial amount of deck repair, and any deck repair that might be needed in conjunction with the overlay is then taken into consideration with the overlay installation. So this is more of the normal application we're seeing with these types of systems. Also, I mentioned about these systems having limited life. So when we're ready to remove the system, can we go back in with another dense system? Generally, yes, you could. And a lot of states are doing that. And the success of these second generation type systems, as I'll call them, is partly based on the deck condition under which that first overlay went down. But typically, again, good long life, 20, 25 plus years is attainable with these second generation overlays under the right conditions. So latex does have good flexibility in its use, variety of applications. It doesn't have to be a last gasp repair or as an overlay treatment. But I also wanted to add in one other neat feature about latex concrete, and that is its ability to be applied not just as an overlay on an existing deck, but also as a shallow inlay. Or in other words, we go ahead and mill out, hydro out a minimal amount of deck, which will generally be about 1.5 inches minimum, and then go back in and place the latex concrete. This inlay approach with the hydrodemolition prep will provide a monolithic type attachment so that the latex will act composite with the deck. The added value in that is no grade adjustments are necessary, and there's the ability to expedite your work, especially when you start to use a rapid setting type cement. So latex modified concretes are very versatile in their use. They can be poured as thin as 1.5 inches, but I know there's some states that have been pouring at about 1.25 inches successfully. Now, there are numerous characteristics of high performance latex modified concrete that help make it very suitable as an overlay product. Higher flexural strength is especially important for these overlays versus the compressive strengths. And this is important to keep in mind against comparison of other products. The reason being, you're looking for an overlay material that is compatible with the existing deck so it can work in unison. Higher strength does not necessarily mean better compatibility. So when the existing deck strength is closer to the strength of your overlay material, the better the two materials can kind of work together with each other. Plus, lower modulus of elasticity helps to reduce the stress buildup at the interface of the overlay and the deck. Latex concrete does provide that good compatibility and flexibility. LMC will provide low permeability numbers, and those numbers continue to improve over time. Styrene butadiene polymers also attract and bond very well to the substrate, and with that reduced stress at the interface, any bond failures with good surface prep being done will be forced into the substrate and not the bond line or within the latex itself. The polymers also serve to help stop any crack propagation internally within the mix. And then also the water reducing characteristics of the mix help make it a more durable, wear resistant concrete and good against freeze thaw attack. Often with latex concrete installations, you see it being used in combination with hydrodemolition, but that's not a requirement. For brand new decks, for instance, a shot blast followed by an abrasive blast or a high pressure water cleaning will suffice for the installation. On lesser deteriorated decks where no delaminations are evident or just very minor patching is to be done, milling followed by an abrasive or water blast is acceptable. Some states still use milling and conventional patching for their main surface prep ahead of these types of overlay installations. But the more aggressive treatment will obviously be in the hydrodemolition prep, where you get the more enhanced roughness and the selective removal within that process. And there's a question on to grout or not to grout ahead of these overlays. And the general rule with latex is where you don't have the real roughened surface, such as your milled or shot blasted surface, there you do grout ahead of the surface pour. Where you have the hydroed surface, generally that grouting is waived. Although on vertical surfaces, such as at adjacent stage construction or your joint areas, barriers, those types of areas would be grouted following proper preparation of the face of the concrete. Latex concrete is quite fluid when it's placed, and then it firms up. It's finished with a self-propelled deck finishing type machine that includes the vibrating mechanism along with drag pan and burlap drag. And depending on the atmospheric conditions, a fogging device may be used. Ideally, if the finish machine smoothly strikes off the surface to the correct grade and the drag pan and burlap drag adequately seal up the surface, then really there's little need to do any additional finishing. And really the best way to handle latex concrete is that less is better when it comes to finishing by hand in there. As it hardens, it's going to develop a crust on the top, so you want to be careful not to work it too much or you risk tearing that crust. And after the finish work is done, a texture will either be applied by raking in the tine while the concrete is wet and before wet curing begins. And that timing is very important because there again, if you wait too long, you can tear that crust when you pull that tine rake through it. For that reason, many states have now gone to post-cure grooving. And the advantage of that is the wet cure can start sooner. That curing process is really the most important part of the entire installation, so it needs to start as soon as possible. Thoroughly soaked wet burlap is the recommended procedure, followed by a secured polyethylene sheeting to keep that moisture trapped in for the wet cure period, which is typically going to be 48 hours. And then there's a 48-hour dry cure period that's associated with it. When time is of the essence, though, an alternate cement can be used in combination with the latex emulsion. And a calcium sulfoaluminate cement can help achieve an adequate traffic-ready strength in as little as 3 hours. Or you could go to a type 3 cement that can be used and it'll gain strength within a 24-hour wet cure period typically. So the curing is very critical, though, with these quicker setting cements to minimize the risk of plastic or drying type shrinkage cracking. So kind of to draw things to a close here, I just wanted to reiterate that latex concretes, they are a specialty type concrete. There are some nuances to installing it, so you can get in trouble if you're not real familiar with the product, and having a well-qualified contractor can make a big difference. I mentioned that this is a mobile mix product. You want want a producer who's familiar with that. There are producers that specialize just in batching the product, but there's also quite a few general contractors out there who have the equipment and can place it. Just the more experience you have as a contractor in batching and working with it, more likely you're going to get a better application and performance. So I'll leave you with 4 key tips. First, have a good tight job spec and adhere to it. Second, insist on a pristine deck surface that's very well saturated upon which to put the overlay on. And then third, in addition to the job specs, lean on the latex manufacturer for some guidance and tips on the installation as well. And along those lines, also use common sense and following just general construction practices, which would apply especially to hot weather and cold weather concreting too. Finally, the curing is absolutely critical. It's probably the cause of most of the problems that are encountered with an LMC overlay installation. And then I want to let you know that there is a latex modified concrete working group out there that can help customers better understand latex modified concrete. The intent is to educate and offer training to all the owners, contractors, consultants out there to help them better understand the proper installation and parameters for which latex modified concrete needs to be poured. So the group they have a few different social media sites out there, so I'd invite you to go follow or like either Facebook or LinkedIn sites. And there's also a YouTube channel out there where you can find 20 different videos out there on a series on the basics of latex modified concrete. So they're just short 4 to 6 minute type clips that touch on different aspects of installing a high quality overlay using latex concrete. If you have a question, there's also an email site you can go to. It's lmcw@bridgepreservation.net. This is the opening session of the webinar on the overview of latex modified concrete, and my contact information is there as well if there's questions. So with that, I guess I turn it back over to John and Bill, and you can round up our next presenter.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.